Right. So we were looking at electrolysis, and I said that electrolysis is very closely related to extraction of metals. It gets used with aluminium because it's quite reactive. Specifically, it's more reactive than carbon. If it's more reactive than carbon, then essentially it makes most sense to use electrolysis. I could react it with something more reactive than aluminium and displace it that way, but that would then, it's just not worth it, because then I'd end up losing that other thing and so on. So with iron and copper, I can use a type of displacement which we can call reduction. I'll look at that later on. And gold, you don't need to use any of them because you found them naturally. Essentially, what electrolysis is you have the ionic compound, which is made out of ions, so positive and negative ions, and the positive ions would be moving towards the cathode, which is the negative electrode, and the negative ions would move towards the anode, which is the positive electrode. But in order for that to happen, you need those ions to be able to flow. So you can't use electrolysis on a solid ionic compound, a solid ionic substance. You could, if you melted it and then they're able to flow, or you could dissolve it and they would also be able to flow. Again, once we look at ionic bonding specifically, it will make a little bit more sense, but this gives you a rough idea. So looking at ionic, this is the actual the structure of aluminium oxide. The reason why it's slightly more complicated than sodium chloride is because sodium chloride is 1-to-1, which means for every sodium ion there is one chloride ion, whereas aluminium is 2-to-3. So for every aluminium ion there is for every 2 aluminium ions there are 3 oxygen ions. Oxide ions, sorry. We also, I just showed over here that this is a picture of them floating, being able to flow, which I made a little video on over here. And then I talked a little bit about why electrolysis is used in aluminium, not iron. So I think I touched upon this at the beginning of this video. And this is an example of another displacement reaction. So I'll just